All right, here we go. Section 3, the hydrosphere. Okay, we've already started talking about the hydrosphere a little bit. Okay, but we're going to go ahead and work on the first part today. What is the hydrosphere? First of all, we know that life doesn't exist very much. The biosphere does not take a lot of Earth. Okay, we don't exist everywhere. But what we do have, where we have water, because water is one of those vital essentials to life. Okay, so where do we find the hydrosphere? Well, we sort of talked about this already. Okay, we've seen some of these information before. Hydrosphere is all the water on or near Earth's surface. Okay, we sometimes refer to different places as reservoirs. Reservoirs are places where nutrient is stored or stays for a long period of time. So one of the biggest reservoirs for water on Earth is your oceans. Okay, we know that 97% of all water found on Earth is found in our ocean. Okay, clouds, because that's included, the hydrosphere does go above into our atmosphere about 1% at any given time. Okay, which means that we only have about 2% of water left in fresh water. Okay, now fresh water is going to be that 3%, that 2-3% that's left. Most of that is going to be in your polar ice caps. 70% of all fresh water is going to be found in those polar ice caps. About 30% of it is going to be found in your groundwater, and the easily accessed rivers, lakes, and wetlands, that's only going to be 1% of all fresh water. So not very much of Earth's water is found in those areas. Now, it does transfer from place to place. That's where you get your water cycle. You should all be familiar with the water cycle. You're going to do an activity on the water cycle, and you might have seen it already. Oh, there's that. I forgot about that. There's your little picture. 90% is in the ocean, 3% is fresh water. Most of it's in the glaciers and the ice caps. Some in aquifers, and only 1% left on land. So you have that. Let's go ahead and go to the water cycle. Okay, a water cycle is just how does the water move through our hydrosphere? Where can we find it? How does it get from one location to another? So you're going to do this great activity called The Incredible Journey, working on that. Okay, and that water cycle, we're going to talk about the time spent in different areas, and that's going to be part of that activity. For precipitation, how long do we have things like snow? Okay, in certain areas. 2 to 6 months for places like the Rocky Mountains, those sort of things. Precipitation coming down and into our soil where it's a little cool, we're a little warmer. Soil can stay, or water can stay in the soil for about 1 to 2 months before it's evaporated out, depending on some of the conditions. In the atmosphere, once it evaporates and it's in those clouds, it's going to stay there on average about 9 days in a cloud. Okay. Evaporation from glaciers, we'll see that's how it gets stuck in glaciers. It can stay in glaciers for 20 to about 100 years. But if we have close places where the ice sheets, it can stay tens of thousands of years, hundreds of thousands of years. And we've seen that with our ice core example. We went back hundreds of thousands of years with that ice core, looking at those different fossils there. So what happens. Now the last one, transpiration. What's transpiration? You should be familiar with this. Transpiration is not evaporation, but it's very close. It's actually vaporization directly from a leaf itself. Okay, so not coming from the surface, but the stomata on the underside of the leaf, those little holes, if you flip over a leaf to its underside, you'll see small holes on the back. Those are what we call stomata, and that releases moisture into the air from the plant. It helps them with their metabolism process, okay? And transpiration, that can vary depending on the location. Transpiration is going to go much more quickly in a place like a tropical rainforest, and much more slowly in an area like a conifer forest, not a deciduous forest, a coniferous forest, the taiga. Okay. Now, where do we find all this fresh water? Let's go ahead and move on to part 2, fresh water. What is fresh water? Basically, it's any water that doesn't contain a lot of salt, an insignificant amount of salt. Now, water does have salt in it, but it's not enough that it's going to taste us or it's going to affect us. Okay. Again, about 1% of all of Earth's 3% of all of Earth's water is fresh water. 1% of it is found in areas. Most of it is stuck in our ice caps, Antarctica. 70% of all Earth's fresh water is in the ice caps in Antarctica. So you can see there, one of the mountains in Antarctica, and the ice that is formed over top of it. 1% of that fresh water is in our lakes and rivers. Well, what's a river system? Okay. A river system is a network of streams that drains an area of land, including the land itself. This is what we call a watershed. So you're going to do an activity on the watershed. The watershed is the area of land drained by a water system. Every area on Earth is part of a watershed. Sometimes we think of watersheds as being high areas, but not necessarily. Okay, I'm going to go ahead and go to the map. We are part of, depending on where you live, we are either part of, in Ohio, the Lake Erie watershed. Okay, and there are several rivers that live there. Personally, I am part of the Black River watershed, where my house is, and that Black River watershed feeds into Lake Erie, so it's part of the Lake Erie watershed. And the Lake Erie eventually flows into the Atlantic Ocean, so it's part of the Atlantic watershed. Okay, so all this area, where does it eventually end up? So if I drop water, if I pour out water into my yard, eventually where is it going to end up? Well, it's going to end up in Lake Erie, which eventually is going to end up in the Black River, which eventually ends up in Lake Erie, which eventually ends up in the Atlantic Ocean. In southern Ohio, though, eventually your water might end up into the Ohio River watershed. Now, Shelby itself sits on 7 different watersheds, and Shelby actually is part of both. It's right on that Ohio divide between Lake Erie watershed and the Ohio River watershed. So it really is very, you're going to be asked to find your watershed, really depending on where you are in north or south of Shelby, is where is your water going to go. Okay. Now, once it feeds into the Ohio River, eventually it's going to end up in the Mississippi River. So southern Ohio is also part of the Mississippi River watershed, which is also, again, going to feed into the Atlantic Ocean. So it's part of the Atlantic Ocean watershed. So here's a map. You might want to write down some of these. We've talked about them before. There's the Great Basin. Okay. That's where everything ends up in the Great Salt Lake. But you can see a couple other different watersheds we have here. And now it is aerial. It is part, depending on where you are. So here's the Ohio watershed. All that land that is in this watershed eventually will drain into the Ohio River. So if rain falls in any of this area, it'll either roll down the hills into the rivers directly, or it'll go into the aquifers, and then aquifers might eventually feed it into the Ohio River. Ohio River meets up with the Mississippi River. So this whole region here is part of the Mississippi River watershed. Now, they divide in Upper Mississippi and Lower Mississippi, which is great. You've got the Arkansas White-Red watershed. That eventually is going to be also part of the Mississippi River watershed. You've got the Upper Colorado and Lower Colorado, again, are all part of that same watershed. Watersheds can be very small and specific, or we can go larger and get them bigger. Okay. Part of the river, one of your last notes, sorry. Part of the river system, it's got a network of streams. That also includes tributaries. Okay, tributaries are smaller streams. So there is a creek near my house that is labeled the East Branch of the Black River. What? In other words, guys, it is part of the Black River water system, but it's a very small branch of it. So tributaries are other small creeks. Now, it has mountains up here, but we don't have to have mountains. I don't have any mountains where I live, believe me. Okay? It's just higher areas of higher elevation. Eventually, they're going to work their way down to areas of lower elevation. Lower elevation in this case, for me, is Lake Erie. For other places, it's going to be the Ohio River. Okay. We call these tributaries, these are called headwaters. Another way we call them is upstream. Okay. There are a couple other different things we have here. We have meanders, you have bow lakes, some other things happening there. Okay. To finish this up, let's go ahead and talk about groundwater. You should already have these notes, so if you're good, you're good. If not, if you missed one of those days, here's the time to get them. Groundwater, most snow and rain trickle through the ground and collect underground. Okay. Less than 3% of water on Earth is found in the groundwater. Okay. We call this storage system aquifer. That's a rock or sediment that stores water. It could be rock, it could be gravel. Okay. We've seen the pictures of it there. Here's your aquifer. So again, it looks blue, but that's just a diagram. Go ahead and draw your little rocks there. So this is rock underground. It has water sitting in the pores between it. Okay. Artesian springs are where the water is forced up through the rock. Okay, that's an artesian spring. Or we can have areas, here's a water table. Water table is just the level. Where is that water in that rock? How far deep is it underground? When the water table goes out beside the rock, there you have a lake or another type of spring. Okay, so you should have that information. All right, so let's go back here for a second. So artesian spring, where water's forced up, where it's saturated. Water table, the line that basically shows us where that water is. Okay. Last but not least on your groundwater, let's talk about how it goes back. If you remember, permeability, how permeable, how easily can that water get through it. Sand is very permeable. We like it. Gravel's even more so. Allows for a lot of space between it. Remember, we had everybody stand at the front of the room and the water bottle travel through the people. The clay is not. That's what clay can make a confined aquifer. Okay. Now, how quickly that water gets in there is called recharge. It can happen very quickly for areas that are highly permeable. A few meters a day are possible, but for areas that are impermeable, but like Atlanta, it's going to be just a few centimeters in a century. Okay, so water's not going to be able to recharge into that area very quickly. We also have the problem where the water gets in there, but it also takes pollution with it, and we can't get out. So you should have all that information now on hitting those rocks. If you have any questions, please let us know. And go ahead and work on your watershed information if you haven't already started that, or your incredible journey. And we'll talk to you soon.